tough course, can be a tough course, material to cover, but we did, okay? Now, here's what I gotta do tonight. Chapter 11, and Michael's not feeling too well tonight, and I usually depend upon him to help me. Guys, please tell me, class, in fact, I think you got a copy of this, probably last Wednesday, where it had a definition for a sequence. And I think I had a student read the definition. And then there was some items to be answered. I think the double side. Guys, check if you have this. I'm gonna get started with this. And then we'll do something else with it. This is all chapter 11 right now. Okay, guys, did we get this? Look at it, please. It says, that's section 11.1 at the top. That's the, yes, looks like we did do it. Burnout. Did you get this? Are you with me on this? No. So guys, what I need to do, okay. Michael, I don't want to call upon you, but you're not feeling very well. Who would like to help me? Because I need someone just to look at that handout, and we're going to work out a few of those examples, and I'm going to explain to you what a sequence is, and what all of a sudden we're going to change the vocabulary into a series, and look at that. And then go from there, and then I got another handout to do after this, and I'll feel good. Okay, who would like to volunteer? To read for me, certain parts from that. Oh my goodness. I have one mission. Got any volunteers? Because I like to start out with, let me do this first though. A sequence, and I'm going to do this, and shortening a series. Sequences and series. That's all chapter 11 mostly about. Okay, I need a volunteer. Who would like to read for me? In fact, I don't think I even have a copy of that particular handout right in front of me, right in one of these packages here. So I need a student here. What's the definition of a sequence? And what's that the first thing at the top? Okay, can someone read that definition for me? Just to remind students what a sequence is. Yes.
A sequence is a function whose domain is the set of positive integers from 2 through 4, and whose range is a subset of the real numbers R.
Okay, so we've got a sequence of numbers, elements of some sort, and she's telling me, Professor, if you have a sequence, and I think I'll jot it down right quickly to get started and remind you what it is. Guys, if I solve this, 3, 9 halves, 27 over 3. I know that's 9, but it's written like that. 81 over 4. And let's make this an infinite sequence of numbers. And make sure I got all that copied out correctly. Then all of a sudden you were asked to find this. Find a subscript, let's say a subscript 15. Which translates into find the 15th term of that sequence. Okay? Now here's the issue. You have to come up with, we have to come up with a formula. Now, we sit here and guess, and maybe someone can see a pattern of some sort. Does anyone see, and we'll write this like this, guys, a subscript n is equal to, that's like f of x. A subscript n is equal to, I need a formula, and after we find the formula, I can plug in 15 and find that number I'm looking for. Does anyone have an idea? Strange numbers. Michael?
3 to the power of n over n.
Whoa, whoa, whoa. 3 raised to the power of n over n. Wow, I'll double check. If he's correct, guys, a subscript 1 in this sequence, if he is correct, says go to his formula and replace n by 1. If if I replace n by 1 here, guys, I ended up with 3 over 1. That's my first term. If I check this one, a subscript 2, that's my second term in the sequence. Put a 2 in. I put a 2 into this formula, is 3 squared, which is what, 9? 9 over 2. Look at that. I'm gonna check the last one that I gave you. A subscript 4, Michael's correct. Put a 4 in, yes, 3 raised to the 4th is 81. So it's 81 over 4. Wow. He has the formula. Now, since you now have the formula, you should be able to express for me at least a to the 15th. Guys, with the help of this formula, it's going to be 3 raised to the 15th over 15. I would not ask you to calculate those big numbers. Leave it like that, and I'm happy. So that's the meaning of a sequence. Now, if I gave you 4 or 5 of these on the final exam, and they were something like this, I know me as a student, it took me a little time to think. Michael gave the answer to me right quickly. It took me a little time to think as a student of this, a formula. These things can be very, very demanding just to find the formula. If you don't find the formula, how are you going to find this? And you don't have the time to go up to and count yourself up to the 15th term. You need a formula. Okay? So that's what this lesson is all about today. There are formulas. Now, we will not fit all sequences, but there are some formulas coming up here. Okay, part B. Jump into part B. So now we know sort of what a sequence is. Now, I need someone to remind me from last week, what on earth, if you don't recall, did we do with a sequence that looks so strange, that has these terms, 1, 1, 2, 3, 5, 8. And they ask you to come up with a particular term, but I need a formula first. Does anyone recall anything at all about that sequence? Was this the Fibonacci mathematician? And if it is Fibonacci sequence, we know we talked about this last week. Guys, the formula, now you guys help me out here. The first term, written like that, a subscript 1, has a value of 1. The second term has a value of 1. After that, there's a pattern. Does anyone recall what the pattern was to get to the next term, then the next term, the next term? The first 2 terms are 1s. Now how can I get to the 2, then the 3? So here's where actually the formula really comes in. Does anyone see anything at all I could write down to come up with the other terms for Fibonacci's sequence? And we did this one last week. What was it? A subscript n minus 1 plus? Love it. A subscript n minus 1 plus a subscript n minus 2. Guys, with that formula, thank you. By the way, it would take all of this to express Fibonacci's sequence. All that should be written. But that last part, let me try 1, 2, 3, 4, 5. Let me try the 5th term. Let me try 6. The 6th term. 1, 2, 3, 4, 5, 6. Let me try the 6th term in this. And see if I get 8. Okay, a subscript 6 by this formula would be a subscript 6 subtract 1 plus a subscript 6 subtract 2. So guys, I'm looking at a subscript 5 plus a subscript 4. A subscript 5, 1, 2, 3, 4, 5 is 5. So I can squeeze in 5 right here. And add to it a subscript 4, 1, 2, 3, 4. The fourth term is a value of 3. If I add those up, I get 8. And that was the 6th term. Is that true, guys? Now, is there a difficulty here? Yes. If I ask you to find the 100th term, what's the issue? In Fibonacci sequence, if you were asked to find the 100th term, way out here, you'd have to find what other 2 terms first? The 99th and the 90 what? 8? Yes? No? Woo! Okay. So I can't do too much with Fibonacci if I did anything at all in the final exam with that. Guys, that's what a sequence is all about. Now, I'm going to follow that up with some sequences, which I like, especially for calculus, are written in a different manner that make it a little bit easier. For example, this. List the first, it's like 5 terms of this sequence. Now that's what they're going to do for you. They're going to actually give you some information. In this first one, the first term, a subscript 1, has a value of -2 in that sequence. And then all of a sudden they give this to me, like a formula. A subscript n is equal to n plus a subscript n minus 1. And they're asking, can you follow this if it's given to you? You don't have to come up with a formula, they give you a formula. Can you come up with the other 4 terms and have the 5 terms? So guys, -2 is my first term. That's given to me. I'm looking for the other 4 that they wish to find. Now let's go to, thank goodness they gave the formula to me. Guys, we'll go to the formula. A subscript 2. Let's go to term number 2, it's missing. A subscript 2 should be equal to, it says n is 2, plus a subscript 2 minus 1, which is really going to give me 2 plus a subscript 1. And a subscript 1, thank goodness they gave it to me as a -2. If I'm careful, this is 2 plus a -2. And guys, if I made no mistake, the second term has a value of 0. Third term. Third term, if I use that formula that was given to me, right here, a subscript 3, be equal to 3, that's n, plus a subscript 3 minus 1, you end up with 3 plus a subscript 2, or 3 plus, now I found a subscript 2 to be a 0. So if I add those up, I get a 3. Do not let me make a mistake. Is that true, guys? A subscript 4, I wish there was a quicker way to do this, but we gotta use the formula. A subscript 4 by formula is 4 plus a subscript 4 minus 1. That's gonna be 4 plus a subscript 3. And that's gonna be 4 plus a subscript 3, I just found it, it's a 3. Add them up, 7. Come on, let's think of these numbers would come out of that sequence. And finally, a subscript, I guess 5, if I follow the formula that's going to be given to me, would be 5 plus a subscript 5 minus 1. That's 5 plus a subscript 4. So guys, it's going to be 5 plus a subscript 4. Fourth term had a value of 7. If there's no mistake, my last term is 12. Is that true? I don't think I made a mistake. Is that true, guys? Okay. Now, would it help if on the final exam Monday that you had a sequence where this was given to you? Rather than me giving you numbers where you get to come up with your own formula. You may sit there for a lengthy time to try to come up with your own formula. So guys, when they do this for you, sometimes they will, especially in calculus, they'll go ahead and give the formula to you. They call this, if they have expressed this in a recursive, they use that word, recursive. Method. So in case you see that word again, recursive, that means they have given you the information for a sequence with the help of a formula, and they call it recursive. Okay, so that would be much easier to deal with. I think, let me see if I did. I did. I gave one more example of a recursively defined. Are you given this information? A1 is 1. A2 is 1. Now the formula, a subscript n is equal to this. A subscript n minus 1 plus a subscript n minus 2. And then may ask you to find or write first 5 terms of this recursively defined sequence. Now please tell me what's going on here. If I follow the formula, they say let the first term have a value of 1. Let's put it up here. Second term, 1. Now, third term, they did not give it to me, but they gave me a formula. So guys, I'm going to squeeze this in right here, and I think we'll recognize right quickly what this sequence is. A subscript 3, which is missing, would be equal to A subscript 3 minus 1 plus A subscript 3 minus 2. So guys, this is A subscript 2 plus A subscript 1. So if you want to find the third term, you must add up A subscript 2, A subscript 1. Thank goodness they gave them to me. If I add these two up, guys, 1 plus 1 gives me what, a 2? That means this has a value of 2. What do you think this eventually comes out to be if I try to find more terms? Is this Fibonacci? This is another way to express something we did earlier. This is the Fibonacci sequence. If the next term should be a 3, next should be a 5, next should be an 8, 13, 21, so forth and so on. Is that true? And I did it by a recursively defined function or sequence. Now, let me slow down. With all that said about a sequence, any concerns? Okay. Now, let's change it into this. Part 2, I'll change my vocabulary. This. A series. On the side here, we use this notation of the Greek alphabet, sigma. I see sigma from the Greek alphabet, that letter in mathematics, it translates into, in all courses, they want you to do this. They now want you not only to write the terms of the sequence, but add them up. Sum them up. And the symbol to indicate they want the sum, not just the sequence, is that sigma. Okay, guys? So I brought in, now see if I'm correct here. Yeah, I'm ready. First, you do this. For an example, here's a sequence but being added, summed up. 2 plus 4 plus 6 plus 8 plus 10. You said, my goodness, professor, give me lots of those on the exam. I can sit there and stand those up. In this case, 6, 12, okay, I got 6, 12, 20, is it 30? When you add up those future terms, are 30? And that's the answer, and you get a check mark on the final answer. Oh my goodness, can you give me lots of those, okay? What I want to do though, because I want you to extend this further, and there's more to it. What I want us to do is maybe rewrite that they want me to do this using this notation. So in other words, I want to show the help of sigma 2 plus 4 plus 6 plus 8 plus 10. Now guys, watch my notation here. I want to use at the bottom here an n. Now I want you to start, let n be 1. When I count the number of terms you're asking me to sum up here, I see 1, 2, 3, 4, 5 terms. So let's go through 1 through 5. Place that 5 at the top. So 1 through 5. Now I got to come up with inside there a formula, something like we were talking about over here. Does anyone see a formula that maybe I can use to get 2, 4, 6, 8, 10, those terms? And I'll place that formula right here, and I'm going to write mine in terms of n. Does anyone have an idea? 2n. 2n. I replace n by 1 to get 2. Replace n by 2 to get 4. N by 3 to get a 6. Aaron's correct there, guys. So that's the way that looks now. The blue now translates into this in the green. Whereas the same thing here. And guys, we know the answer for this is 30. That one's simple. You're done. Isn't that cute? Of course it is. Now, what could be hard about it? If you did this. 2 plus 4 plus 6 plus 8 plus 10, and so forth and so on, out to, let's say, 100. How do you want to add those? I get a grand sum. Now let's use the sigma notation first and express it in terms of sigma to show what they're asking me to do here. The guys, the summation, here's my symbol. And we usually do start with 1 at the base. What should go at the top, do you think, on this one? 1 through what?
50.
Is it 50? Or is it 100? Michael says it's 50. Throw this in there, Michael. And it's also 2n being used like a formula inside there again. Is that true, guys? Expressed in sigma? Now, let's see if he's right. If I replace n by 1, Michael, right here, I get 2, which is right there. If I replace n by 2, I'm replacing by integers, I get a 4. But if I can reach the top and replace it by 50, which is my stopping point, do I get 100? Okay? And then they'll ask you, please sum those up. Don't just stop there and get an answer. What's the grand sum of that? Now, does anyone have an idea? What would you do as a clever student to add up 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 and go all the way through 100 and get a grand sum? Any ideas? And we have it written already as a sigma summation. Any ideas? No? No ideas? I know it's a Monday. Any clever ways to add those up?
Can it be related to the following 5?
Okay, could be related to be more.
Maybe we just multiply by 10, the previous one?
Oh, you mean go back up here on the one I had up here? Right here?
Yeah.
And multiply that by 10?
100.
Because if I multiply by 10, my grandson would be 300, right? And then you say, oh, maybe it's 100, Professor. 100 times 30 is going to be what, 3,000? We've got to be careful. I'm not saying one of those is wrong, but I've got to come up with some little plan here. Let me mention the guy's name. Could Gauss's method work here? Michael and I were talking after class last week. Remember Gauss, the one who did the adding backwards and came up with it real quickly? Now, if you're desperate and you have no help, right down to the help of the formula, to get the answer, you could say, well, Professor, could I squeeze in? Here we go. I'd like to squeeze in, I see sigma there. Let me squeeze in the red here, guys. Could I squeeze in and say, hold on, won't you add backwards? 100 plus what, 98? Plus 96? Plus 94? Plus 92? And go all the way over to, what is it, guys, 2? Did I write backwards? Is it written backwards? Yes? No? If it is, then from Mr. Gauss, is this the observation he made? What about the sum of these terms here? Are all those 102? So I have 102 100 times, I think. Is that making sense? Is it, guys? Is it making sense, or is it 50? Which one is it? 50. You think it's 50? Okay, hang on. By the way, what's that number at the top, 50, you guys up here, not 100? And then divide by what? 2, since you actually did this twice. That's what Gauss's method was. Now, if I clean this up, Mr. Park, help me out, please. What's 25 times 102? Let's hope we did it correctly.
2,550.
Do it again.
2,550.
7500?
No, 2,550.
2550.
Yeah.
Oh, yes, 2550. Parker, you saying that?
Mm-hmm.
2550?
Mm-hmm.
Okay. Okay. Guys, if I did Gauss's method correctly, where we add backwards, I hope I did it correctly. We saw that, what, last week? And it looks like you're gonna do 2550. Now you're saying, Professor, for goodness sakes, suppose I did recognize that I could do this with Gauss's method. Is there a formula? Is there a formula I could apply here somehow, maybe recognize a formula, Professor, not Gauss. Recognize the formula, go through it again, and get 2550 again. Guys, let me see if I have a handout for you. It might be on that hand, I don't think it is. Would you please flip it over? Someone help me out here. Flip that handout. Was there a series of formulas given for summations? Now, I don't have the time to write them all down the board. They were listed on the back of that paper. Okay? Is there one that looks like this? In fact, someone give these formulas to me. The first one mentioned, guys, was what? Summation of what? Did I start with 1? And did I call it K? At the bottom, K is equal to 1 or N is equal to 1? K. Okay, they used a K, I think, in your textbook. And it went through N. N's my stopping place. And inside here, what was the very first formulated volley? What did they have inside there? Summation starting from K is equal to 1 through N of what?
CA subscript K.
Oh, C. A subscript K. Like that? Okay, so if I see it, please tell me, did they allow me to move that C, which is going to be a constant, out front, if I wish, by that formula? Michael, did it look something like that?
Yes.
Okay, so you're allowed to move the constant, if you have a constant, out front, if you set this up correctly here. I gotta find a formula that relates this over here. Now, Michael, do me a favor. The next one, I think, says, let's go from 1 through N again for summation. Was it like A subscript K plus B subscript K? So if I see something like that, what am I allowed to do? Do they split this up into 2 different summations? From 1 through N of A subscript K, plus also K is equal to 1 through N of B subscript K. Do they have it written like that? So they're saying if I have a sum or a difference, I can split it up. Okay, almost like distributing sigma on those terms. Now, Michael, do me a favor. Now, let's get down to where it says summation of, I think, K is equal to 1 through N. I'm trying to think how it may be expressed there. I guess of K. Is there one that looks like that? Okay, tell me what it may look like. From 1 through N, or I should ask someone else. He's not feeling too well. Did it look like this or not?
Yeah.
Everyone see that on the handout, guys? K is equal to 1, start at the base. K is equal to 1 through N of just merely K. And it looks like that. What am I allowed to do for this, to find the sum right quickly? Please, was it N times N plus 1 over 2? Was that the formula they gave me? Okay, guys, we got all the formulas enlisted. Then apply those formulas to what I have over here. Next one, they're saying, please be responsible for it. If you see this, summation, we'll start with the 1 through N. Was there 1 for K squared? And that one was, help me out, guys, n times n plus one, make sure I get it correct here, 2n plus one, was this one all over six? Yes or no? Okay. Did I give you one for k cubed? Okay, I didn't, I held off on that one. So I think when you reach the calc course, I think they may go up to k squared. There is k cubed in case we would need it in the textbook. Okay, I got some basic formulas. Besides that, what else did I give you in terms of a formula? Help me out a little bit.
CN,
How much now?
C.
Oh, CN. Beautiful. Okay, summation. And you're saying from 1 through n, and you're saying CN. What do they allow me to do if it looks like that? Do they allow me to move the C out front? Is this the way it looks?
It was C equals CN. Sum of C equals.
What did we have written down wrong?
Yeah, summation C equals CN.
C,
Equals
C is equal to this.
C.
I think had this written down in paper. Oh, yeah, I got you. I think. You guys are saying just C here.
Yeah.
Okay, and the answer is, if it looks like that, what do they give for an answer? NC, CN? And that's another formula. Whoa. Is that all I have listed there, basically? Are those the formulas? Are there more out there? There are plenty more out there. But I think this will be enough to get through that Math 7 course. Okay, guys, here goes. Jeez, try to find where I am. Okay. Let's go back to, we did this by Gauss, this problem. And we got an answer of 2550. Now, I'd like to do it, since I have a formula here. Where am I? Let's put it right here. So we have a formula where we're trying to sum up from 1 through 50 of 2k or 2n. We'll put a k, guys, since these formulas like this. I'd like to now do it and apply what formulas I can apply and get the answer by formulas rather than Gauss. Right, here's what we were asked to find. And we did it by Gauss, about 2550. Anyone tell me what you would do first if you saw it like this and you want to apply something from the formulas? Which formula looks like it might be best to jump into? And I have only 1, 2, 3, 4, 5 formulas listed. Which one would you try first? And try to simplify the green. Which of these formulas may be best to start out with?
K equals.
How about this one? Is there a constant inside here? Did I have a constant? 2? Can I move that 2 out front? So I could start out with a 1 odd. If I have a constant, that formula says you may move that 2 out front. And that would leave me, which may help me. Let's go from 1 through 50. Now I'm just merely left with k. So I started out with the first formula. Now to go further, please tell me, can I do anything else with that? Sigma. Is there a formula that I could apply there? The summation of k, is that this one? So I can have 2 out front, and then I could now apply by formula, from your handout, this formula. So it's n times n plus 1 over 2, n in this case is 50, so it's 50 times n plus 1 will give me 51, all over 2. 2's will cancel. 50 times 51, I think, is what, Mr. Park? What's 50 times 51? 2550 again? Same answer?
Yeah.
Okay. Then they performance. Okay, now, someone tell me, because let's see how much more I have to do on the handout. How many more problems I ask you guys to try? Oh, not too many. Okay, here comes one here. Guys, I'd like to sum up from the handout, summation. And it looks like I like to start with the one down here. It looks like it's through 14 of this expression. K squared subtract 7k plus 2. If I have it written down correctly. Now, if I jump in and try to find the grand sum, and you add all those up, let's write a few of the terms out. If I let k be a 1, guys, here goes. If I replace all these k's by 1 and do the math, I see 1 subtract 7, negative 6 plus 2. I think you start out with a negative 4. The second term, replace k by 2, right here. 2 squared is 4, subtract 14. 4 subtract 14, what's that, negative 10? And the negative 10 plus 2 is a negative 8, is it? You're not letting me make a mistake. Is that the value of the second term if I replace k by 2? Right here. 4 subtract 14, is it? Negative 10 and negative 10 plus 2 is that negative 8? Third term, if I replace k by 3, I get 9, subtract 21. Guys, by 3, 9 subtract 21, how much is 9 subtract 21? Negative 12? And then negative 12 plus 2 is what, negative 10? And it goes on like that until you finally replace k by 14. Which is going to get big. So the term on the end, I'm going to see if I really need it, but right now, if you put a 14 in there, that would tell you the value of the 14th term. Mr. Parks, since you're going to help me out here, on your few days you have left with me. Guy, what is 14 squared?
14 squared.
Then subtract 7 times 14 plus 2. In other words, evaluate this for me at 14. Let's see what that last term looks like.
100.
How much?
100.
100? The last term's 100.
Yeah.
Wow. When you replace k by 14,
Mm-hmm.
okay, he says it's 100. So guys, supposed to add them up. Negative 4 plus negative 8 plus negative 10. And the last one was a positive 100, right? Park?
Last one?
It's a positive 100?
Yeah.
Okay. You're supposed to add them all up. Who has the time to add all this up? I don't. Okay, let's use formulas. Let's see what the sum should be. Now the formulas, guys, if I apply the formulas and not do it this way, which would take forever, let's split this up, which is allowed. I'm going to rewrite that summation as 3 terms. Summation from 1 through 14, k squared, subtract another summation, from 1 through 14 of, put the 7 out front, guys, which is allowed, then k, and then on the end, plus summation, we're going from 1 through 14 of merely 2. There it is split up. We're going to try to find that grand sum by using formulas. Okay, understand how to split this thing up. Now let's apply the formulas. The first formula, look at this. Looks like, it's going to be a little messy, you have to apply this formula. The k squared formula. N times n plus 1 times 2n plus 1 all over 6. Guys, in this case, that would be 14, that's your n, times 15, that's n plus 1. Double 14, 28 plus 1, 29, what a mess. All over 6. And of course, I'm going to have to come back to that. I hope those numbers are in there correctly. That's the first one. The next one says there's a 7 stuck out front, which I could move out front by one of those formulas, and leaves me this. I need to sum up from 1 through 14 of k. That is this formula. So replace n by 14 by the formula there, you're going to end up with, right here, 14, n plus 1, 15, all over 2. And finally, when I finally reach the end, a summation of a constant, oh my goodness, that's this one. It's got a constant of 2. It says we're going to find it right quickly, multiply these two together. In fact, I think of it as multiplying those two right there together, c times n. So in this case, it's 14 times 2 for the summation. And therefore, the summation simple is gone. We've done the summations with the help of formulas. Now you gotta crunch this out. And I don't know, I may have called Mr. Park again. Guys, do this, I'm gonna take 6 into 14, or am I? Oh boy, it's gonna be messy. I can reduce it down by maybe a 2, put that marker there. By 2, make this a 7. I'm just trying to do the math here, guys. 3. I could then take 3 and 15, you get a 5. Mr. Park, what's 35 times 29?
35 times.
Yeah, let's get that first one out of the way.
1,015.
1,050?
15.
15.
Yeah.
So it's 1,015. Next one says 7 times, this one's a little bit easier. Cancel 2 into 14 is a 7, just doing the math. 7 times 15 is 105. I'll come back to that. On the end, 14 times 2, if I did it correctly, is 28. Wow. That true, guys? I hope. Okay, I got 1,015. Subtract 7 times 105. Park, what is that? 7 what? 735? 7 times 105.
7 times 1, yeah, 735.
35 plus 28. Mr. Park,
763.
what's the grand sum there when you add all that mess up? It's 1015, subtract 735 plus 28. See what the grand sum is, without me standing here trying to do it all in my mind here.
252.
How much?
252.
How much?
252.
252.
Yeah, I'm wrong.
Oh, I don't know, I haven't looked yet.
Yeah.
252. Guys, 1,015 subtract 735, I don't want to take too much time for that arithmetic, but let me see what it is. In my mind there, that would be, my goodness. 280. Hang on. 180, yeah, 280. 280 plus. Mark, you sure? I don't know. Did someone add those up on your own?
I have a question.
Yeah.
So over there, it's 14, over 15, and over 25 in the beginning, like.
Oh, over here?
Oh, I got
So
308.
25, it's probably 25.
Mistyped it.
Whoa, hang on. So this number here?
No, up, a little bit. In the beginning,
Oh, up here,
yeah,
right here.
yeah. How do you count?
I just, read these numbers here. I got those numbers.
Like 14, over 15, and over,
I mean, right in here is where your concern is.
yeah.
Okay, I'll reduce that now. Park, do me a favor, because I'll reduce it down quickly. Just do it the long way. 14 times 15 times 29. Little time on the arithmetic here. 14 times 15 times 29, then divide that by 6.
Oh, yeah.
1,015.
Wait. So we got 1,015 last time.
Yeah.
And now you've changed it to what?
Same.
Oh, it's the same.
Yeah.
So I think that's, are we okay with that, guys? That's what it works out? Oh, no, that's the hand went up. So we got 1,015 or not? Is that, we agree with this one? We agree with this one? This one, I did a little thing here, 105. Well, guys, what was it? Times 7, do we agree with this one? 735. This one was at what? Was it 14 times 2, 28? Now, what's the grand sum, Mr. Park?
I got 302 at the calculator.
30, how much?
2.
302.
Is it
Yeah, 308. 308.
Whoa,
My bad.
Mr. Brown. 308.
Yeah.
You guys read now? His grandson, 308. Okay. Now, see what you guys are going to be up against here and crunching all these numbers. Now, guys, what I'm trying to emphasize here, you gotta know your formulas. There's another professor like this, we had summation formulas, we had trig formulas, half angle, double angle, A plus B, and now you tell me we need to do more formulas. No more formulas to work these out. You do. Okay? Michael, remind me, was there any other problem on that handout? Oh, there's one more. And this chapter 11 almost is finished. Okay, from 1 through 90. Let me go up here. Summation from 1 through 90. And Michael, inside there was what? Let me see what it looks like.
3 minus 2i.
3 minus 2n. Oh, I used an n, so those are k, so I need a k here. Guys, you can use an n or a k there. Let me write a few of the terms out. If I replace k by 1, I get 3 subtract 2, which is 1. If I replace k by 2, it's going to get interesting here. 3 subtract 4 is a negative 1. Right, k by 1 by 2 by 3, 3 subtract 6, negative 3. And it goes like this until I reach the last term, and that says replace it by 90. So 3 subtract what, 180? What is 3 subtract 180, guys? Negative 177, I think. Yes or no? So they're saying to add all those up. Oh, good luck. Thank goodness I got some formulas. I would not sit there and try to add all those up myself. So guys, by formulas first, let's separate this into summation from 1 through 90 of merely 3. Second term, subtract, that 2 can be moved out front. And you're left with for sigma 1 through 90 of k. Is that true? Now, with the help of the formulas, let's see what that final answer may look like, guys. Here goes. The first one, right here, to find it right quickly, I would rely upon, let's see which formula do I need here, guys. I think it's this formula right here. C times N, it's the formula there. Which merely says 90 times 3. I love this one. That's 270. The next one says 2 times. The next one, the way it's written, has a summation for k, and that is this formula, n times n plus 1 over 2, so that would be 90, 91, all over 2. N times n plus 1 over 2. Clean this up, 2's will cancel. Here we go. It's 270 subtract, oh my goodness, 90 times 91. Someone help me out. Is that 8,190? I did that real quick. 90 times 91, I think. And then 270 subtract that, guys, going to be a negative answer. Mr. Park, if all that's correct, tell us what 270 subtract 8,190 is for a final answer. It'll be a negative answer.
So it's like 2.
270 subtract 8,190.
Negative 7920.
7920.
Yeah.
You guys, so it's 7920. For what we were looking for there. Okay, so it all comes into, I'm doing a little erasing here. Summation formulas, summation formulas, summation formulas. Yes. here. That's when I applied the formula. Oh, if I did like, Gauss's method.
Yeah.
You remember he divided by 2 because he actually added twice. He went this direction first and he turned around backwards. Is that true, guys? He actually added twice. To compensate for that, he divided by 2. Is that true? Woo! Alicia, it's almost over. But not quite. Guys, any concerns here? Chapter 11 is going to be closing out here shortly. Now, here's the way I gotta close it down. Let me see if I got some handouts. Michael, I think you're telling me on the handout that you have there right now, that was the last problem. Was it? Okay. Guys, I'm gonna do something interesting. I've changed my teaching method so many times throughout the years. And I thought about you guys, this particular class. I'd like to try, oh boy. Here goes. To lead into closing down of chapter 11 here shortly. With this problem, just for an introduction to how they end the chapter. Guys, all this, I need to erase it. Here we go. Now, you're not gonna get a full appreciation of all this until you're sitting in a math 8, maybe, I don't know, was it math 8, you guys saw a lot of sigmas, summations?
Yep.
Okay. Where they're gonna do some calculus. With this. Yeah, John?
For the Gauss's method, why didn't you also divide 102 by 2? If you did it to the 50?
No, the 2, I canceled out just one time, it was just canceled out one time.
Oh, you can't do it?
I took 2 into 50.
Well, you can't do it to the.
No, you can't do it to both. Ah, good question though. No.
Did we get like a paper with this on it,
On what now?
on Gauss's method?
No, I think I just mentioned gas.
Uh,
I think I actually had it on a handout. Right. Didn't we do Gauss, guys, last week? Mr. Gauss?
End of the lecture.
Yeah, exactly. And I was all about formulas. Okay, here's what I want to look at. Let me just get enough space there, raised. To introduce, us closing down shortly, chapter 11, I'd like for us to look at this summation. Now we're using some different notation, but still summation. At the base, I've been using N or K. Here, they're gonna use a J. So J is gonna start out with, of all things, 0, not 1. Because I can't use one of those formulas we're discussing, so there's a 0 there. Goes through 2. And inside here is something strange. 2 with J placed underneath it. X raised to the 2 minus J. Y raised to the J. At least the sigma's there. It's strange notation. If anyone can tell me what the solution to that is right now, I may say, stay home, Lindsay. You've passed the course. You don't have to worry about taking the final exam, which is 3 hours. And I thought it'd be a good way to introduce closing down chapter 11 to that problem. And I doubt, unless someone has some experience with this, that anyone can tell me what I'm looking for. What is the answer for that? Are we shocked? Or are we shocked? The answer is a middle school solution. But those kids across the street there are not seeing, I don't think they're seeing sigma. But the result, if I show you what the result is for us here, for the sigma, you will get what they've done across the street. Anyone have an idea? Okay, well, I gotta jump into it. Here we go. I need some notation. First, just move into this. try to close down this chapter 11. Guys, notation. First, we're saying, please have students to be introduced to that notation. And looks like an exclamation mark. Just in math, have students know what that notation means. It's read as in factorial. What it means to do is start out with n times n minus 1 times n minus 2 times n minus 3 until you reach in that product 1. That's called n factorial. Now, on the side here, if I have everything written out correctly here, guys, let's try to find 5 factorial from that brief description of what factorial means in math. It means to start out with, in this case, 5. Next to it, times n minus 1 would be 4. N minus 2 would be 3, 2, and it will stop when I reach 1. So you start out with the number they gave you and go down to 1 and form the product. In this case, if I multiply all those numbers together, 5 times 4, 20 times 3 is 60 times 2, 120. There's 5 factorial. So I need that notation to go back to my problem up there. I notice the textbook says, if students see this, don't be shocked. They accept that as a 1. Looks like it should be a 0. It's not though. It says 0 factorial. Please take it as a 1 by definition. So I'm not going to argue with them. 1